Continuing with the series on the alternator conversion into a stepper motor, this is the actual Visual Basic code that I use. It's a very simple application. I used a single form. You can see that I dropped several controls onto the form here, a couple of slider bars, text windows, command buttons, and timers. We'll look behind each one of these controls. We'll look at the code behind them to see exactly what's happening here. On form load, you can see the very first thing that happens is I do a call out to 888 decimal, which is 378 hexadecimal, which is a little bit more familiar value to people that have actually worked with the printer port or the parallel port. One of the things that you'll need to do is a little bit of shopping to implement this. You're going to need a DLL, and I'll show you the declarations for that. You'll need to be able to download that off the internet. It's a free download. I have one code module defined, and the only thing that's really in it is this declaration right here. If you'll go out and Google for this input output 32, you'll be able to find a very comprehensive package that will allow you to, from Visual Basic and actually from a few other programming languages, allows you to manipulate the hardware ports directly, which is a no-no that you can't actually do without a special driver that has some kernel mode access with Win32. See that continuing here, you'll see that I'm only turning the clocks off, the four timers that I have, and initializing the endpoints on the slider bars. This particular one I'm setting to 1,000, which represents milliseconds in the interval. The other slider I'm setting to percentage. I can go from a minimum of 10% up to 150% of whatever the value is in the interval window. Setting the sequence, which is really actually the coil, to 1, and the mask is the actual value that goes out the parallel port. The mask is also displayed in this text window right here. So when you click on the start button, the only thing that really happens is the coil interval is initialized. That particular timer, which is the very first timer, is initialized to the value that you got set in text 1, which right now I have a default set to 1,000 milliseconds, or 1 second. Then you can also see that I go ahead and enable that timer and start it running. Now it will take, from the time that I click this button, 1,000 milliseconds, or 1 second later, this timer will fire. When this timer fires, you'll see that it picks up. It actually checks its own interval first, and this, of course, is done every time that this timer triggers itself. It re-evaluates the value that is in text box 1 in the event that you change the interval. You can also see that it computes the RPM at this point, the 16 steps per revolution. It also goes and reads the values in text 1 and also in text 2, uses those two values to compute the interval for the on time for the coils. Goes ahead every time this timer fires, it reevaluates those values and initializes them. The next thing that you see happen is this call fix mask, which is the little kludge that I put in there for the hardware issue that I've got with my port. We'll go down and just take a quick look at it. You can see that essentially what it's doing is that if the sequence is equal to 3, this would normally be bit, let's assume it's D0, 1, 2. This would be D2. Normally the mask would be set, in which whatever the current mask is, whatever bits are set, you would R in the next coil, which would normally be a 4, but in my case, since I've skipped that particular bit, I'm using an 8. You can see also here that if that's not the case, that the mask is just R'd in with whatever the sequence number is. So that would be whatever particular coil is being fired, that particular bit is R'd in with whatever's already in the mask. After this fix-up takes place, you actually do the output. This is the only place in the code that a coil is actually turned on at this point in time. It's either a coil or it's 2 coils are energized. One would be previously energized, and you would energize a second coil. This would be if the percent of the interval is more than 100%. See that after that it goes through this case statement where it basically evaluates what sequence it is and turns on the appropriate timer. Again, assuming that the timer was 100% and it was 1,000 milliseconds, that would mean that exactly 1 second after this statement is executed, you would vector down to this interrupt right here. This interrupt would occur, timer 1. At that point it would simply turn off bit 1, and the way it would do that is by taking the mask and ANDing it with the decimal value 14, which basically says turn off the low order bit D0. And again, you would go ahead and call the output to the printer port and turn that particular bit off, and then at the same time you would turn this timer off. You can see that timer 2 and timer 3 are basically the same thing, except the mask turns off a different bit. It would either turn off bit 1, bit 2, or I should say D0, D1, and normally it would be D2 at this point, but in my case it's D3. After the case statement is executed, you'll see that text box 3, which is essentially the coil number, is set to whatever the sequence value is. Then the sequence is incremented. It's tested to see if it's greater than 3. If it is, it's reset back to sequence 1. That's really the program. It just loops around in that timer until you come up and select the stop button. And at that point, the only thing, again, it knocks all the bits down to 0 on the printer port. It turns off all the clocks, any of them that might happen to be enabled at the time, and resets this bit mask, the text4 value to 0. Back to the form, the only thing that we haven't really talked about are the slider switches and how they work. There's not really but one line of code behind each one of these. Take a look at the second one. Essentially it's just setting the percentage that's displayed in text box 2 to whatever the position is on the slider. So that's it. That's the rest of the code. It's very simple. It's very easy to modify, and I would say it's still a work in process. Can't say whether it's